So I'm going to remind you of 3 different units you've used in the past, and then also introduced another unit. Now where we're going with this is we're actually going to know these units so well that we're converting between them, but just this video is about reminding about 4 different units. So this would be an example of a problem. You would have a solute like KBr, and you're putting it in, added to, that means that the other one is the solvent. You always do the solute into the solvent. The smaller thing goes into the bigger thing, making a solution that is this many liters. So that's your solution. So notice I've got solute going to solvent and solution. I've got 3 different numbers. Now, I'm going to go ahead and play around with these numbers and get them into units I know I'm going to need for these other units that I'm solving for. I don't recommend that you do this for every problem because it's going to be extra work. But just for this situation where I'm explaining what we're doing, I think it's helpful to go ahead and have some of them already converted around. So the first one is this moles of KBr solute. I just want to remind you all that 0.05 and that 00 moles, if you use this is from adding the K and the Br on the periodic chart. You can get it into grams if you needed that for your unit, or you could go ahead and do a conversion and get it into kilograms if you needed that for your unit. So I'm just pointing out that when it says moles, don't forget it's really easy and fast to go ahead and convert it into grams or kilograms. Kilograms is kind of a thing in this chapter. It really matters to one of the units, so just pointing that out. Now on our kilograms of water, remember that's easy to get into grams as well as moles. So I'm just pointing that we have that information too. You can take your 1 kilogram right here. You can use that conversion. Remember the 1 goes with the prefix and there's 1,000 grams in it. So 1 times 10 to the third or 1,000, whichever way you prefer to write it, of water. And then I can go ahead and again use the numbers off the periodic chart, which hopefully you've memorized water by this point. And then I can get it into moles. Notice on all of these situations, I'm continuing my sig figs that I had to begin with. So I'm going to go ahead and stick this up here. I'm going to put it, kind of squeeze it in over here as this part of the problem. So this is, again, I wouldn't do this personally for every problem. I wouldn't like convert all the units around, but this is, you'll see why this is helpful as we work this problem along. Another unit you may end up being given in a problem might be density, and that density will work with your liters of solution. You won't need it right now for how I have these all set up. All right, so let's get started. We're going to start with the percent mass, and you did this before in Gen Chem 1 when you did empirical formulas. So percent mass is a unit. We're going to do grams over grams, and this is grams of your solute over the grams of the solution. Note, they can also ask you for percent mass of the solvent. So pay attention if the problem's asking about it, because with these units, you could do either way, really. This one tends to be grams of solute, though. So, and then that's times 100%. So I'm going to just take my grams, and I'm looking at my numbers for my solute, and it's over here. That's where my grams are. So 52.5. And then solution, that's just adding the 2 masses together. So 52.5 plus, and then over here, let's see, I need to make sure I'm adding any grams to be consistent with my units. There's my grams of water, 1,000 grams of water. I'm going to make a little space here. And by the way, that would be like 1.00. I didn't write it out that way, but if you're wanting it, it's 1.00. It's got the 3 sig figs. And so when I put this in my calculator, I'm going to do 52.5 divided by parentheses, 52.5 plus 1,000. And that gives me 0.049. And if I'm trying to get 3 sig figs, notice that the 8 beside the 8 will round it up. See, it turns out like that. That's going to round him up so that my number turns out to be 4.99. And then the unit there is percent because my grams have canceled out. Now, I didn't multiply it times 100, did I? Don't forget the 100. So that's what that'll make it look a lot more like a percent. That was a fraction how I wrote it originally. All right, now, if you did have to, like, say both, let's say they asked you for the solvent percent mass and the solute percent mass, that's easy because there's only solute and solvent in it, so they should add up to 100. So just 100 minus the 4.99, and then that should be 95.01. Nope, 96. 95. Sorry, I'm double checking my math here. Percent. So that's how much water, if they'd wanted to know the percent mass of water, that's that one. If they want to know the percent mass of the KBr, that's that one. So it's not too hard to get between them if you wanted to. Or let's say you accidentally solve for water and then you're going back, you read the problem, you're like, oh, wait, it said percent solute. It's really easy to get to it.